Good afternoon, everyone. Welcome to the New Jersey Climate Change Resource Center's Summer Climate Academies webinar called The Cost of Climate Change. This particular webinar is co-hosted by our colleagues at Climate Central, and we're so pleased to be able to present the work of partners between Rutgers, Climate Central, and others. My name is Jean Herb, and I am an executive director of a research center at the Rutgers University Edward J. Blaustein School of Planning and Public Policy. And along with my colleague, Dr. Marjorie Kaplan of the Rutgers Climate Institute, I co-direct the New Jersey Climate Change Resource Center. So let me just cover a few logistics for today's webinar. The webinar is about an hour, will last until 2. Other than today's presenters and the Rutgers team here, you're all muted. So to communicate with us, please type your questions into the chat box. To find the chat box, look at the bottom of the screen and you'll see a little bubble that says chat, and you can click on that and send us questions and comments. Please send your notes to panelists, and that ensures that all of us that are working behind the scenes today can see your questions and make sure that we present them to the panelists. Thanks so much to my colleagues, Matt Drews and Dr. Carrie Ferraro here at Rutgers for their help with today's webinar. We appreciate hearing from all of you, so we do hope that you'll offer us comments as well as questions. We're recording today's webinar, and it will be available on the Climate Change Resource Center's website, and I suspect also on Climate Central's website, and I will put the link for that website in the chat in a minute. One continuing ed certificate maintenance credit has been approved for this webinar through the Association for Floodplain Management. And if you need a certificate for that, please contact us and we'll work with you on that. So now I'd like to begin the webinar, the conversation, and we're pleased today to have 3 colleagues to present this challenging topic, which we know will be something that is going to generate a lot of discussion here in New Jersey as well as nationally. So first, Dr. Dan Daniel Guilford is a climate scientist at Climate Central, where he focuses on exploring sea level rise projections, structural and parametric uncertainties in glaciological and atmospheric processes, and observational constraints. His other research interests include the impacts of climate change, such as increases in human heat stress and coastal risks, as well as the role that the policy process plays in challenges posed by climate change. Dr. Guilford holds a PhD in atmospheric science from MIT and a bachelor's of science in meteorology with a minor in applied math from Florida State. Next, we'll have Dr. Robert Kopp, Bob Kopp, who is a professor at Rutgers University and the director of the Rutgers Institute of Earth, Ocean, and Atmospheric Science, and co-director of the Rutgers Coastal Climate Risk and Resilience Program. My colleague, Dr. Kopp, is known internationally for his work on numerous scholarly endeavors, including being lead author on the IPCC's forthcoming 6th assessment report, the U.S. Global Change Research Program's 2017 4th National Climate Assessment, and work on economic risks of climate change called American Perspectives. Dr. Kopp has chaired 2 science and technical advisory panels on sea level rise here in New Jersey, and he has served as a sea level rise expert for groups in the states of Maryland, California, and the cities of Boston and New York. And then our third presenter is Rob Freudenberg, who is the Vice President of the Regional Plan Association's Energy and Environmental Programs, where he leads the organization's initiatives in areas including climate mitigation and adaptation, open space conservation and park development, and water resource management. Rob's been with RPA since 2006 and most recently served as its New Jersey's director, where he managed the state's program on sustainability planning and policy. Prior to joining RPA, Rob was a managed coastal management fellow at NOAA, where he worked here in New Jersey with the State Department of Environmental Protection. Rob holds a Master's of Public Administration in Environmental Science and Policy from Columbia, and a Bachelor's in Environmental Biology from SUNY. It's a terrific panel of great policy and scientists, policy experts and scientists. I know we're going to have a wonderful discussion. So now I'm going to ask Bob and Rob to come off camera with me, and we'll turn it over to Dan Guilford to present first. Thank you.
Well, thank you so much for that introduction, Jean. We are excited, very excited to share this new work that we have been developing at Climate Central over the past several years. It is a study where we have been trying to understand how Hurricane Sandy could have been influenced by climate change that has occurred over the past century or so, and how much damage that could have accounted for. As we know, Hurricane Sandy was quite a damaging storm along the tri-state area. So just for a little context on that, in October 2012, late October, Hurricane Sandy made landfall along the Northeast in the tri-state area coast. It was an incredibly strong storm when it made landfall, especially for this particular area, and it brought with it a lot of storm surge and a fairly high amount of surge associated with both high tides and the sea levels at the time. We have been working to try to understand how climate change could have affected this storm. So I'm just going to give you the top level results, what I'm calling the Sandy ledger. Those are sort of the key ideas. So I already mentioned about Hurricane Sandy's background, but the storm caused a significant amount of damage, especially from flooding sources, and the losses incurred are estimated at something like $53 billion. So it's a quite expensive storm to sustain, as well as the many lives that were impacted at local levels through either housing changes, impacts on jobs, resources, those kinds of things. This study, our key finding in this study, which is Strauss et al. In Nature this year, found that about 13% or $8 billion of those total losses were caused by sea level rise from human greenhouse gas emissions since about 1900. So over the last century, we put a certain amount of sea level increases into the ocean. Those drove up the background sea level on which the storm surge occurred, and that increase caused about 8 billion of the $60 billion that we estimate during hurricanes. So how did this occur? Well, since the pre-industrial period, we have been changing the atmosphere and ocean that we live with by increasing the greenhouse gases in our atmosphere. So as these greenhouse gases go up into the atmosphere, they trap more energy. That energy is then released back down to Earth, which warms up the surface, and the ocean can then contain more heat. As the ocean grabs more heat from the atmospheric warming, the seas begin to expand, much like if you were to boil a pot of water on your stovetop, the water would expand there. That's the exact same thing that's happening with the oceans as they continue to heat up. But also with that warming comes melting ice, just as if you were to set an ice cube out on the counter as exposed to that warm atmospheric temperatures, that ice would begin to melt. And that's what's happening with land ice all over the planet. It's starting to melt, slip into the ocean, and its increased mass from that ice causes water levels to also rise around the globe. Those higher sea levels then mean that there is a higher background on which water can be pushed inland as the storm arrives. So as Hurricane Sandy arrived, it arrived with higher sea levels than it otherwise would have had if climate change had not occurred, which caused more flooding overall. But a big question you might ask is, everything I've just described is sort of happening at a global level, but when we're thinking about Hurricane Sandy, we really care what's happening at a local level. What happened in the area local to New York, the tri-state area of Connecticut, New Jersey, New York? How did sea levels change in that area specifically because of human activity? And how did that increase Sandy flooding? And I want to be really careful to highlight here that by human activity specifically, we mean the emission of greenhouse gases in this particular case. So how do we go about this? Well, we can think about it sort of with what we call an observed case, a counterfactual case, and then the difference between those two is what is human caused. So the observed case is what we actually go down and measure. We have tide gauge stations that are around the tri-state area coast. Those measure a certain amount of sea level change that we have experienced over the last 120 years or so. Now, we understand that this sea level change is not entirely caused by human caused sea level change. So there's probably some natural component. So we need to pull that natural component out and understand how sea levels change specifically related to human causes. The way that we pull that natural component out, that component which we call the counterfactual here, which is this blue line, is by modeling what the sea levels would be if greenhouse gases had not been emitted into the atmosphere. So we run our sea level models with and without greenhouse gas emissions and the warming associated with those. So we get some projection that is associated with observed warming. We get some projection that is associated with counterfactual changes in the ocean. And we take the difference of those two curves over time. And the difference as it lands in 2012 is about 10 centimeters of change. So this change in sea level is not very large, but it's going to make a big difference. And we can take both observations that we are looking at, as I said, down at the tide gauges, or observations around the world, how ice sheets have changed, how the oceans themselves have changed, how mountain glaciers have melted and contributed to sea level. And we can produce a harmonious estimate of how sea level changed in this region. We compare it then to the counterfactual and get some estimate of human caused sea level rise. And then we can add that with flood and damage modeling to get total estimates of damage associated with Hurricane Sandy through this increase in sea levels. Our harmonious estimates that we've taken this world rejected here, this counterfactual, and instead of accepting a world, or instead of taking a world where we would have no human emissions, instead our estimates are projecting that the damages from Hurricane Sandy are something like $4 to $14 billion in damage, with an average of about $8 billion, which is again about 13% of the $60 billion that was seen during the landfall of the storm. So the key numbers that we can take away from this study are as follows. Over the past 100 years, we know that human-caused sea level was at least 1.3 inches high, but it was very likely much higher than that, on average about 4 inches. These higher sea levels mean that the background sea levels on which the water is being pushed inland is now higher. This allows water levels that would be already on the coast to actually increase in height. So that means infrastructure that wasn't necessarily at risk from a small amount of water before, that extra 4 inches could have provided quite a bit more infrastructure damage associated with it. And also the increases in sea levels allow water to go further inland, which means more inundation downstream where you wouldn't have had water if the sea level hadn't occurred. This means overall more damage, both from higher inundation and from more inundation inland. That more damage leads to about $8 billion as our midpoint estimate. That's our 50th percentile. And in the range of losses can be anywhere from about 4.7 billion, which is probably no less than that, and could be as much as 14 billion which is our 95th percentile estimate of damages associated with human-caused sea level rise. On average, this meant that about 70,000 more people were affected by Hurricane Sandy than would have been if human beings had not increased greenhouse gases in the atmosphere. And about 36,000 more houses in the tri-state area experienced flooding during Hurricane Sandy than they would have in the absence of human-caused sea level rise. So I'm going to leave you with this table and you can sort of take it in, but I want to emphasize 2 key points with this. One is that we know that human beings are right now affecting the climate system. And this means that we are seeing damages right now that we can pinpoint and associate with human-caused sea level rise. And the advantage of the framework we developed in the study is that not only can we apply it to storms such as Hurricane Sandy, but we can go back in time and apply it to many different storms that have occurred over the past 100 years, try to understand how, in our flexible framework, damages by human-caused sea level rise could have arisen. So we're still working on that part of the project, and the system is very flexible to allow us to do that. And the key sort of final takeaway I want to leave you with is that the damages are really quite substantial for a fairly small amount of sea level rise. 4 inches is only about a hand's width across, but it caused $8 billion more in damages than it otherwise would have. So these decisions that we make as a species is how we are going to change our environment going forward and have already. They make a big difference when it comes to money, and it makes a big difference as far as the human effects of how lives are changed and affected by these extreme climatic events. So I thank you so much for your attention, and I'm happy to take any questions at the end.
And thank you so much. That is an amazing body of work, really incredible. I'd like to now ask Dr. Bob Kopp to turn on his camera and microphone and join us to provide his insights on this research. Bob?
Great. So Jean asked me here to provide a little bit of context on this study that Daniel's talking about. So I'm going to spend the next few minutes talking about the cost of climate change more broadly, both in the sense of what are the costs of climate change today and what are the projected future costs. So throughout this, we're going to structure it around a few key points, one of which Daniel already emphasized, right? Climate change is no longer an issue for the distant future. It's already affecting people throughout the world, including here in New Jersey. And when we think about this, we're diving into this world of scientific studies that go by the titles of detection and attribution. So detection studies are basically asking the question, has this large-scale global change that humans have been working on the climate system by trapping greenhouse gas, and has that caused some part of the climate to undergo a statistically significant change? Or, for instance, extreme sea level events, extreme high tides coming more frequently than the past, regardless of their causes. And then the attribution is saying, well, how much has humanity through our emissions contributed to this detected change or to the change in an intensity of an event? So at the broadest level, the way you go about the attribution question is by doing this sort of counterfactual experiment that Daniel was talking about. What would have happened today, or in some event you're talking about, had those greenhouse gases not been in the atmosphere? And so climate models are a key tool here, because climate models embody our understanding of the physics of the climate system and allow us to do these experiments we can't do in the real world. What had happened if we went back to 1850 and no more emitted carbon dioxide into the atmosphere? This plot here is showing you what climate models tell you. In blue, a temperature would be in a world without human-caused greenhouse gas emissions, and the red or pink, what they are in a simulated world with human-caused greenhouse gas emissions. And so the basic point, this is the sort of #1 attribution study, is that climate models can only reproduce the warming that we've seen over the last 40 to 50 years when you include greenhouse gas emissions from humans, and that of the observed warming since 1950, somewhere between about 90% and 120% is due to human factors. So roughly all of the warming since 1950 is caused by humans. Now, that's at the largest scale, but we can ask these questions about particular events. For instance, heat waves. These are sort of the easiest type of weather event to untangle the human influence in, because it's so direct. We're making the planet warmer. When it is warmer, a given heat wave is going to be warmer also. And so we just need to understand, well, how much does that extra, 2 degrees Fahrenheit of warming that humans have caused, how much does that make the event warmer? So some of the early work on this goes to things like the 2003 heat wave in Europe. And studies have shown that climate change made this heat wave, which killed about 70,000 people, killed about 3 times more likely, and that about 2/3 of the deaths that happened in 2003 wouldn't have happened without that extra boost from human-caused climate change. Over the following decade, it became about 3 times more likely again, and it's continued to become more likely since. And this is going to be a pretty broad conclusion. If you see a heat wave on the planet today, the planet we're living in is one that's been affected by climate change, and that heat wave is more intense than it would have been without human-caused climate change. But we can also make these sorts of studies about other events. For instance, in a warmer planet atmosphere, you can store more water vapor in the atmosphere, so you get more intense rainfall. This is a photo from Hurricane Harvey, which had very intense rainfall, which was the primary damaging mechanism. And that intense rainfall, more than 50 inches in some areas, was, according to these attribution studies, made about 3 times more likely as a result of climate change. And one recent study, sort of similar in spirit to the one that Daniel was talking about, found that the human contribution to this increased intensity caused about $13 billion of flooding in the Houston area during Hurricane Harvey. There are other sorts of events where we can also make attribution statements. When you have higher temperatures, you get more evaporation, and so that makes droughts more common and intense. And of course, right now, the Western US is suffering through a very intense drought. And wildfires, when you get hot, dry conditions, and again, it's heat that is easiest to attribute to climate change, you get more wildfires. Studies have shown that roughly half of the wildfires in the Western US since the 1980s would not have happened without that boost from climate change. Now, bringing it nearer to home, temperatures are rising in New Jersey faster than the global average. We've experienced nearly 3.5 degrees Fahrenheit of warming here since the early 1990s. And we've also seen this increase in the intensity of rainfall. In the US Northeast, since the 1950s, the amount of rainfall following an intense event has grown by about 55% in our region. And as Daniel was talking about, the ocean is rising globally and even faster here in New Jersey. Since 1911, we've got about 18 inches of sea level rise in coastal New Jersey, which compares to about 8 inches in the global average. Now, this difference is due predominantly to natural subsidence, sinking of the land, about 7 inches, and to local human influences caused by pumping groundwater, about 3 inches. But of that, as Daniel was talking about 4 inches locally are due to human-caused climate change. So we're seeing sea level rise enhancing storm-driven flooding, as Daniel was just talking about. And as he just mentioned, roughly 13% of the damages in the tri-state region and about 100,000 people exposed would not have been without the influence of those extra inches. Sea level rise is also making high tide flooding more common. In Atlantic City, we've seen an increase in the frequency of high tide flooding from about 1 event per year in the 1950s to about 8 inches per year over the last decade, a period over which sea level rose by about 9 inches. And this is a study from collaborators in Rhodium Group. Due to sea level rise, all of those factors, not just the human contribution, about 27,000 more New Jersey properties currently experience annual flooding than would have in the 1980s. And this plot here is showing you where those are. So most concentrated in Ocean, Cape May, Atlantic, and Monmouth counties. And average annual losses from hurricanes have increased by about $1 billion since the 1980s in New Jersey, concentrated in Hudson and Bergen County, where the highest value of property in the state is. Now, that's the current situation, but we're continuing to emit greenhouse gases into the atmosphere, and every additional amount of greenhouse gases emitted makes climate change more severe. So at a rate of about 0.4 degrees Celsius, or about 0.7 degrees Fahrenheit per trillion tons of carbon dioxide. So current emissions are therefore warming the planet up at a rate of about 0.4 degrees Fahrenheit per decade. Now, I want to very briefly show you some work focused on understanding the economic costs of climate change out of a collaboration I co-lead, the Climate Impact Lab, which is a partnership between Rutgers, the University of Chicago, Berkeley, and Rhodium Group. And this is a photo of our rather extensive team. And our goal is to use big data approaches to looking at how humans are impacted by climate and extreme weather, to look at what the current and future risks of climate change are, with the goal of raising awareness, influencing policy, particularly by improving estimates of the cost of climate change that go into things like regulatory policy, and by providing local information to help improve resilience. And when we think about this, when we do these sort of future analysis, we have to think about the range of future emissions, which, depending on what trajectory we're on, if we were to continue the trajectory of the early 2000s, we might be looking at a doubling of greenhouse gas emissions by the middle of the century. if we sort of stick to where ambition is now, we might be close to plateauing emissions through the middle of the century, this moderate emissions trajectory. And if we were to achieve the ambitious goals laid out in the Paris Agreement, we would be on a trajectory leading us to near zero emissions in the third quarter of this century. So when we think about emissions, we have to think about the future effect. We have to think about this big choice we're making about global emissions. With this high emissions trajectory sort of landing us in the range of 8 degrees Fahrenheit of warming over this century, the middle one landing us in the range of 4 to 5 degrees Fahrenheit, and this lowest one landing us in the range of about 3 degrees Fahrenheit, so just sort of the internominal international target or thereabout. So our team is working on looking at impacts in a range of different categories, including mortality, agriculture, energy, labor, conflict, crime, migration, and coastal damages. But I want to just very briefly show you some of the work we're working on human mortality. And to do this, what we do, I said, is it's a big data approach. So we have to assemble really large data sets. So we've assembled, going to these countries, what we believe is the most comprehensive and self-consistent set of mortality statistics in the world, which we then go and link to daily weather data to understand how much a particular day contributed to the mortality statistics for a year in a particular county. And so what we find is that mortality is most severe from heat waves in areas that are poorer and in areas that are not as accustomed to extreme heat. And so we can use this relationship to project forward and say, okay, has places become wealthier? Has the planet warms up? How do we expect deaths from heat and cold to change into the future? And so we can get projections like this. So this is showing you in a high emissions future, there are some areas in blue where there is a greater reduction in cold deaths than an increase in heat deaths. And then a lot of areas in red where there is more of an increase in heat deaths. But what's really interesting is when you start to break down who is in these particular places. So this plot here is showing you on the left projected deaths and projected costs of adapting to climate change, broken down by low-income countries, middle-income countries, and high-income countries, and by areas that have currently hot climates, currently mild climates, and currently cold climates. And the basic story you should take away from this is that, one, these deaths are a lot. You can see some reference levels on the right. And if we're in a high emission world, we're talking about climate change causing deaths of a scale of things like cardiovascular disease. And two, people in low income areas die from climate change. People from high income country areas don't really die that much. They may even see a reduction in deaths, but they have to spend a whole bunch of money to avoid dying. So bottom line is that people in low-income countries die from climate change. Those in wealthier countries largely spend money to adapt. And second point, so that was a high emissions trajectory. Here's what, if we just sort of keep with the pledges, of sort of roughly what countries claim they want to do now, not even getting onto the most ambitious Paris Agreement goals. Just flipping back and forth, this is high emissions, this is moderate emissions. Getting even to moderate emissions reductions cuts the mortality risk from climate change by about 80%, while still leaving this sort of climate injustice element there. Even with this reduction, it's still the poorer countries that are seeing the most deaths, high-income countries that are avoiding deaths by spending money to adapt. Now, one of our goals in the Climate Impact Lab, as I mentioned, is to inform benefit cost analysis for regulation. And so we can use this to say, okay, well, how much damage is done when we put a ton of carbon dioxide into the atmosphere alone? And what we find using standard valuation approaches is that putting 1 ton of carbon dioxide into the atmosphere, through its influence on human deaths, causes about $20 to $40 of damage. And for reference, US emissions are about 6.5 billion tons a year. So the effects on human health of the damage we're causing with our emissions are on the order of $200 billion a year now and into the future. So I want to conclude with 2 reminders. One is, there's a big influence of emissions. to stabilize the global climate at any level of warming, whether we're landing at the international 2 degrees C or one well below 2 degrees C target or some higher level, requires us to bring net greenhouse gas emissions to zero. And even in a world with a stabilized climate, we also need to manage the risks we don't avoid, which is why groups like the Climate Change Resource Center, which are here to help communities and businesses take climate change into account through design, adaptation, and mitigation strategies, are so critical, and we need to scale these efforts up in order to manage the risks that we are creating for ourselves. Thank you.
Bob, thank you so much. Thank you so much for that compelling talk. I really appreciate it. And then now I'd like to ask Rob Freudenberg from RPA, Regional Plan Association, to come on. Rob is going to give us some reflections in terms of thinking about the implications of this research for policy and planning, not just here in New Jersey, but within the region and nationally. So Rob, I'm going to turn it over to you.
Excellent. And Jean, can you see my PowerPoint?
I can.
Can you see my slides? Okay. Let's see. So I can figure out how to make it larger. So thank you, Jean. Thank you, Bob, and thank you, Dan, for these preceding presentations. They've been great. And I think question I want to pose today is, it sounds a little crass, but so what? We've heard these great attribution studies, and we see what's at stake from what Dr. Kopp presented. So now what do we do with that practically? And I think the answer to this is that there's a lot we can do with this, and this is great. So I'm gonna go through and tell you a little bit about that. First, I'll just briefly introduce the group I work for and why we're doing what we're doing. I work for a group called Regional Plan Association. We're a nearly century-old organization focused on research, planning, and advocacy for the New York City tri-state metropolitan region. We are long-range thinkers, and we are regional thinkers. So dissolving boundaries, issues like climate change clearly cross boundaries and transcend boundaries as well, which is why we are so focused on it. This is our region, 3 states, portions of 3 states, 31 counties, 782 municipalities, 23 million residents, over 13,000 square miles. The work we do is founded in regional plans that we put out once a generation. You can see we put out one in the 20s, one in the 60s, one in the 90s, and recently one in 2017. Now that 4th regional plan that we released in 2017 really tried to tackle issues that some of the other plans hadn't focused on, in particular issues of climate change and equity. We entitled it Making the Region Work for All of Us. And one thing, in addition to kind of the major features of the plan, we had an entire section dedicated to rising to the challenge of climate change. Our 3rd plan, just out of interest, 1996, had about a 1.5-page spread on it. And the message was, this is such a big threat. It basically says we think things will be figured out, but if they're not, they're going to be bad. And that plan was right, unfortunately. So apologies, it's a little grainier when it's big, but this is our region. And one of the reasons why we're so concerned about climate change in our region is because it is a region of water. It's essentially our region distilled down to 2 things, land and water. You can see all the little streams and rivers and everything in the watersheds that lead to the big waterways. We have built in ways and in places that now put many of us at the risk, the front lines of climate change from flooding. We did some work back in 2016 using the methodology from Kopp et al. I'm proud of sea level rise 1, 3, and 6 feet, and how much land would be permanently inundated. And these aren't insignificant numbers. These are the places at the highest risk where we'll see continual inundation. And then obviously there's a whole layer back of all the other threats from climate change, and then those that'll see the non-permanent inundation that happens as well. All told, about over 2 million residents by 2050 because of sea level rise, because of increased flooding will be at risk of flooding in our region. That's a significant portion, and something we need to figure out and change policy and act on. And we're glad to say that, you know, since we did this plan, the 2016 plan of sea level rise, there's been a lot more action in this space at state levels and local levels as well. So back to the question of, so what do we do with this information? You know, we are learning more and more, and we're understanding more and more. And how can policymakers and elected officials and residents and businesses, what can we do with this information? So I've kind of divided it into three questions, or three ideas of why this particular study is really important at that level, the practical level. And the idea here is, what I think is most powerful about this study is that it takes climate change from this abstract concept, this thing that we're all, or many of us, if you believe in it, are afraid of, and are seeing the impacts of, but we're still just not sure what is it really doing. It takes that abstract concept and brings it to be more concrete. And that's really critical if we're going to drive change and really understand what these are, these impacts are, and what we can do about them. In particular, I think one thing that's really important about this study is that it speaks the language of Sandy, what I called. You know, and I saw in the chats, you know, I just said Sandy here. I didn't say hurricane or superstorm. And I see that maybe it's not even either of those. It's kind of not really a hurricane on its way to a nor'easter, Sandy, but that's probably too long to say. But, you know, Sandy is the climate touchstone for our region. It is the thing that woke a lot of people up to the effects of climate change, for better and for worse. It's driven a lot of the policies that are being enacted today, driven a lot of the projects that are being done. And it's the thing that many of us can relate to. It's only less than 10 years out from when we experienced it. So this study, looking to Sandy, I think does really good service in that it looks at this cultural and climate touchstone that many of us lived through, to try and say what we're up against. The other thing that's really important is the study talks in dollars and cents, and recognizing this isn't a perfect scenario. The amount of damage that it references is probably nowhere near the real damage that Sandy caused. Still, we have these numbers in our heads, over 60 billion, nearly 70 billion. And it says there's a real dollar and cent value that climate change is responsible for. Any of us kind of working and needing to pay the bills knows that dollars and cents talks. We need to know, you know, you don't want to lose money. You don't want to spend money that you don't have to. And climate change is driving us to spend more money than we otherwise would have had to. And I think that's a really powerful message that comes away from this study. Finally, it looks backward to Sandy in order to look forward. I think some of the things that Daniel was talking about was, you know, this storm, while we can look way back and see the damage from storms, it gets us thinking ahead to the next storm or the next extreme event that has climate impacts. We don't like, we don't like to be fooled by things. We don't like to be caught unaware. We are no longer unaware that these storms cause more damage and cost more dollars than they otherwise would have. So hopefully that motivates us to look forward and say, okay, there are things we need to do to ensure that we don't get cheated out of this, and that we can maybe find a way to address climate change a little more proactively and urgently. Aside from kind of the value of this study in terms of what it communicates is what it's able to do with policies, climate policies and goals. I think Dr. Kopp's study showed that we are seriously facing consequences from climate change, and they're going to get worse, and we know that. And there are things that we at a local level, at a state level, at a national level are doing and trying to do to ensure that the worst doesn't come. This report gives extra ammunition to help justify what we're doing. If there were any questions, if there were any doubts about why we need to do this, everything we just talked about before helps to justify that we should be doing this because it's going to get worse. That was just 4 inches of sea level rise and more is coming. So we need to get these policies moving. And this is at both the mitigation level, whether it's here in New Jersey, implementing the Global Warming Response Act, the different pathways to reduce our emissions 80% by 2050, the Energy Master Plan that helps kind of guide the decisions around these things, or other policies. We really need to double down on mitigation in every way, because we don't want to be facing the consequences that are going to be getting worse because of this. Again, this study is really powerful in helping us to justify these things we're doing and maybe helping us to do them quicker and more effectively. On the adaptation side, it's similar. We have a number of things moving along in the state right now, which is really important. NJ Pact includes new rules to establish special permitting zones where we regulate the coast differently. We have to make harder decisions on the coast, and these rules are being open for public comment now, being considered, and there's opposition to them. This is the kind of study that can help to justify rule changes and really make differences and say we can't keep doing things the same as we've been doing them along the coast. In a similar vein, the state's Earth Day release of the Climate Change Resilience Strategy includes over 100 recommendations of how we as a state can become more resilient. I think the idea that these strategies need to be moved on and implemented is given further justification through a study like this. And then there's the public investments that we're making. If we are making any investments to make sure our infrastructure is better protected, our residents are more protected, this study justifies that. It doesn't just justify it for the places that we are in, say, the flood zone, the places beyond as well. So there's good justification from this study. The final thing this study, or the other thing this study does, is help to shape the future climate policies and actions. So there's what we have today that we can justify, and then there's what we need to look ahead to. And whether it's regulatory map determinations, NFIP reform, all the things we're trying to figure out with how we regulate these areas prone to flooding. This study says climate change is changing the nature of this, and we need to change those determinations as well. It can even help us. New Jersey is really lucky to have a buyout program, Blue Acres purchases. This is the kind of study that allows us to look at where we want to be looking ahead to future Blue Acres purchases. It helps us, local master planning. There's a resilience piece of local master plans that are now required, and the local communities can rely on this study to help justify the actions that they'll make. And again, the public investments, the future public investments we make. And then something I always like to get on a soapbox about is that we don't have a dedicated ongoing funding source for adaptation. I think this study should indicate that we're going to need more funding going forward if we're going to adapt or change the behaviors so that we don't have to keep investing in places that are going to see more funding. And then I can't underscore the importance of equity in this. Those who have less means, those of disproportionately overburdened by poor planning decisions of the past, they're at the front lines of climate change. And a study like this really helps to ensure that the decisions we make going forward aren't going to disproportionately affect those populations again. So finally, I'll just close on saying, how we communicate this, since it's kind of, I put it out to you, the audience. How does a study like this, how do we use the findings of the study to communicate differently to different audiences? The state and local elected officials that are making these decisions about where dollars are spent, the residents about the decisions they're making on where they should live and how they should invest in their homes, and the business community where they're making decisions depending on the business, whether it's where to locate, how to serve their customers, or if you're a developer, where are you going to develop and what's the smart decision to make there. So there's a lot this study does. I'm thrilled it's here. It's going to help me in my work as I communicate with residents and policymakers. And I'd love to hear what the questions are from folks moving forward. Thank you.
Thanks so much, Rob, for such a thoughtful discussion. I really like your expression of looking backwards to look forward. So I jotted that down. So I'd like to invite Dan and Bob to join us as well on camera. And I'm going to turn it over to my colleague, Dr. Carrie Ferraro, who's been monitoring what looks like to be a very busy chat box. And we can pose some of the questions in our remaining 10 minutes or so. Carrie?
Thank you, Jean, and thank you, Rob and Bob and Dan, for such wonderful talks. I appreciate it. We received a lot of questions, so I tried to put as many as I could together. Dan, we had some questions about the methodology and how it could be applied in other ways. So there was a question about whether it would be the Sandy methodology that you used would be repeatable for maybe past or future disasters and in different locations or that have historical sea level records.
Absolutely, yeah. So that is one of the main reasons we sort of started looking at this. Of course, Sandy is very important for our local area here in New Jersey, in the tri-state area. But it's also important to look at the history of what we have experienced here in the U.S. globally, or what we may experience in the future, as both my colleagues have mentioned. So I think it's important that we created a framework that could do that, and we have. One of the challenges with going to other places is you have to account for the different distributions of water across the planet. You know, we can think about how global sea levels have changed, but local sea levels are impacted by quite a bit of different things. As Bob mentioned, there are local changes in our sort of policy decisions or the way we're interacting with our environment, or even changes in the way that glaciers have moved over the areas we live in over time that are, of course, going to affect how our local sea levels are changing. So when you're looking at different places, you can apply the exact same methodology we've done here, but you have to localize it to a very specific place that you're interested in studying. And by doing that, and in order to do that, you have to look at specific things like how oceans have changed, if the circulation of the oceans have changed nearby where you live. You also have to think about how ice sheets are changing. For instance, ice is very heavy and actually is so heavy that it attracts its own gravity. So as you melt the ice, particularly, for instance, in Antarctica, you lose some of that gravitational attraction, and then the water sort of bumps up on the other side of the planet. You also have the Earth underneath the weight of the ice sheet starting to sort of bounce back up around the ice sheet itself, which causes water away from that source to actually bounce up. So when Antarctica melts, for instance, we here along the east coast of the United States get quite a bit more water than if Greenland melts, because Greenland is nearby. And so you have to think about those particular processes and think about how they change your local sea levels. And our system is designed to be able to extend to looking at more locations like that.
And I would to add on the future storms, in many ways, that's an easier problem than what Daniel's taken on, because we can, by the time you're looking out the later in the century, the fraction that's of sea level that, the fraction of sea level that's not human caused is diminishing over time. And so more or less, if you're looking at a future storm, you just want to know what future sea level is. And in fact, that I showed some slides from a Rhodium group study of flood risk in New Jersey that was not looking at the attribution question, was just looking at changes in sea level. And I showed the stuff that was focused on from 1980s to today, but that report also did look forward to 2050. And so that's one resource for our state that does in fact do that. And we have other work on coastal risk forward looking going on in that lab as well.
Thanks, Bob. Carrie, other questions?
Yeah, thanks. So we had a question about kind of do you have a sense of who's going to pay these costs. And is it going to be really the government, or do we think that citizens are going to have to pay more? Any kind of projections on that?
I mean, I can jump in on, since we've done some work into looking at funding streams for adaptation in particular. This is hard. This is, in a way, it becomes the government's responsibility to ensure the safety and well-being of its citizens. So tax dollars are for sure a question here, an opportunity. And I think we can see what's going on in Washington, D.C. For all of its problems. They're trying to figure out how to use taxpayer dollars more effectively here. The hard part is that will not nearly be enough. We even as it's whittled down further and further. So it becomes a question of priorities of where we spend our tax dollars, how much our tax policies, and then there are other ways we can get. If we can find ways to engage the private sector in this as well. It can't all come on the back of taxpayers, but I think there's more creative solutions required here. But by no doubt, public tax dollars are going to be the primary source of paying for adaptation and mitigation.
Thanks so much, Rob. A great answer. So this next question is for you, Bob, and you may not have an answer to this, but I'm going to pose it to you. So there was a question about, you showed some slides about the cost of health, climate change and the cost of health. And so there was a question about whether there will be, whether you're doing any work around future costs of healthcare costs. So how the future healthcare costs might also be played into this impact, the climate impacts.
Yeah, so it was a great question. So the study we've done on health is focused on death rates. You could do a comparable study on hospitalizations. That might be harder to do a global study on because the rate a death is more commonly defined in different places than hospitalization. But the basic approach of trying to understand how something that matters to people, whether it's deaths or energy demand or hospitalizations or number of hours worked, changes in response to weather today, and how that relationship varies in different places that have different levels of wealth and different levels of baseline climate. That's a methodology that can be broadly applied, and we're seeing a profusion. It's not on our agenda, but there's definitely a profusion of these sort of climate econometric studies out there, and that would certainly be a good topic for, say, somebody's thesis to work on.
A true professor talking. Carrie, I think we have time for one more question.
Great. So we received a number of questions kind of on the mechanics of climate change and how it all works. So I'll try to get at that the best way that I can. And we received a couple of questions about COVID-19 and climate change. And so I thought that those might be a nice way to tie that together. So whether you've kind of seen any reversals of climate change since the entire planet shut down due to COVID-19, and any comments you have about that, about how the system might work.
So a couple of things to keep in mind. So one, the climate doesn't really care about emissions of CO2 in any given year. It cares about cumulative emissions of carbon dioxide, right? So 2020, there was roughly a 6% or so drop in global emissions. That, is a minuscule impact on cumulative emissions. The planet still warmed at a very fast rate in 2020. There was and perhaps still is an opportunity as we restart the economy to bend the curve of emissions downwards, and which would have a significant impact on cumulative emissions. Unfortunately, that's not the direction in general we seem to be going at the moment, and emissions are sort of heading upwards again. But the important thing to remember with CO2 is that it's cumulative emissions, right? Every ton of CO2 you put into the atmosphere makes the planet a little hotter, and the most of that increase in temperature will last for many centuries. And so, 6% decrease is nice if it's the start of a trajectory, but 6% decrease in emissions on its own essentially does nothing for you, right? It's the getting to net zero that you have to keep as your goal.
Thanks, Bob. For folks who have expressed an interest in COVID-related issues, I'll let you know that just last week we had another Rutgers faculty member, Dr. Panos Georgopoulos, give a presentation on research that he's been leading on looking at the intersection of climate and COVID. And so I urge you, if you have that interest, you can go to the Climate Change Resource Center website and see that recording. Carrie, I was wrong. I think we could do one more question and then we'll close out.
So I think what we had a question kind of about the paper in that you had shared. And so there was a question for the link. So I'm going to go ahead and put about what the link was or how to access that information. So I'm going to go put that in there. Other than that, the other questions were, I didn't expect to have one more question, so I apologize. I should have had one in the hopper there. So looking at, so if we were going to use the methodology that you used, Dan, and then we were going to use it looking into the future, would you do it under different, I know you talked a lot, it's really local, and so would you have to use different sea level rise scenarios for that as well?
Yeah, that's a really great question. So we know that, the amount of change that you may see in a different component of the sort of the hydrological cycle, the way in which water is sort of circulating around in big reservoirs, for instance, the ice sheets, the trajectory that we follow, our sea level follows, is really important. And so how each one of those components responds to the emissions you put in the atmosphere individually will affect local places very specifically. So if you were going to look at locations in the future and try to understand how they would be more susceptible to increase attributable sea level rise, one thing is you can sort of follow what Bob was saying earlier, which is that over time, more and more of the sea level that we're going to be seeing will be attributable. In this study, we saw that 55% of the sea level at sort of the average amount, our median estimate of changes of sea level in New York was attributable to human causes. In the future, that proportion is only going to grow because of changes in ice sheets in the oceans. So you have to look at each one of those components individual, but over time, as you change the amount of greenhouse gas in the atmosphere, you're going to get changes that are associated with that. So it would be good to look at a broad range of scenarios, especially if you expect there to be a diverse range of policies that are implemented or considered.
Thanks, Dan. So we're going to close out now, and I want to really thank so strongly all three of our presenters, Dr. Dan Guilford, Dr. Bob Kopp, Rob Freudenberg from the Regional Plan Association, for amazing conversation. Again, the recording of this webinar will be posted in about a week on the Climate Change Resource Center website. We urge you, everyone, to take a look and see some of the other presentations that have been given over the last year or so. And we'll be coming back together for the Climate Change Resource Center's virtual academy in the fall. So we'll be taking a little summer break. So we look forward to seeing you all then. Thanks everyone for joining us. And on behalf of Rutgers University, the Climate Change Resource Center, and our colleagues at Climate Central, we thank you for joining us today. And we'll close out the webinar. Take care.